Howdy, 7th grade. Today we're going to be talking about how to make some formulas for sequences. So first I want to talk about the two different types of sequences, and that's going to make the formulas make a little bit more sense. Then we'll jump right in. So if y'all remember, when we talked about sequences, there are two types. And the first type is arithmetic, and the second is geometric. So when I say sequence, just as a quick reminder, a sequence means that we are going to be talking about a list of numbers. So these lists of numbers change in different ways. The most common one is going to be this arithmetic way. And an example of what that sequence would look like. So if I have an arithmetic sequence, it could look like, I'm going to write this inside a bracket to say it's a set of numbers, 2, 4, 6, 8, and so on. So we can look at this and we can tell that it is an arithmetic sequence because we add between numbers. And in this specific arithmetic sequence, we are adding 2. So in this one, we're adding 2. The other kind, which I'm going to do in pink, would be a geometric sequence. And an example of that would be 1, 3, 9, 27, and so on. And if you look at this geometric sequence, what's happening here is we're not adding, but we are multiplying between numbers. And in this case, we are multiplying by 3s. So what we want to try to do is make a formula for this. So if I asked what the, say 20th term was, so what the 20th number is, I want to be able to find that out. So it'd be way over that way, and I don't want to necessarily go through every single number and then count to 20, but I want to be able to figure out, what that number is. So a quick example of this arithmetic sequence we have. So for this arithmetic sequence, right down here, I'm going to write this as in, just one second, I'm sorry, I wrote that wrong, it should be a sub n. A sub n, and what this means is the nth number, which sounds weird, but if n is 1, that means it's the first number. If n is 2, that means it's the second. If n is 4, that's the fourth number. That's going to be equal to 2 times n. And we can check to see that this works. So if I want to figure out what the first number is, I can plug in a 1 for n. And if I plug in a 1 for n, then I'll end up getting 2 times 1 is 2, which is my first number. If I want to figure out what the fourth number is, I can plug in a 4 for n, and 2 times 4 is 8, and 8 is my fourth number. So it looks like this works pretty well. So I want to try the geometric one real quick, and then we'll look a little bit more into the intricacies of making these. So how this geometric number is going to look is I'm going to have a of n, so my nth number is equal to 3 to the power of n minus 1. And I should have written this a little bit differently because I know this is going to be confusing. That's all right. We are going to try first plugging in a 1 here. So if I plug in a 1, I have 3 to the power of 1 minus 1, which is 3 to the power of 0, which is 1. That means my first number should be a 1, which I have, which is great. 3 to the 2 minus 1 is going to be 3 to the 1, which is 3. So my second number would be 3, which I have. And just for fun, if I do 3 to the 4 minus 1, that would be 3 cubed, which is 27. So my fourth number should be 27, which I have up here as well. So the question here is, how are we going to write these sequences? And the answer is pretty simple. We're going to, we'll start by looking at our arithmetic sequence. So for any arithmetic sequence, we'll always be adding by a number, and I'm going to call that number k. So since I'm not quite sure what number it'll be, I'm just going to call it k so we can think about it a little bit more generally. So if k is 3, then we might have a sequence that looks like 2, 5, 8, 11, etc. In any case, we're going up by 3 every time. So that's how we can tell it's an arithmetic sequence. We are going up by a number every single time. We're going to call that number k. So how we're going to write this sequence is that for any number, it's going to be its spot, a sub n equals k times n. So what that means is every time we go over a step, we can think of that as that needs to be adding another n. And if we add an n every time we go over a step, that means we're going to multiply the number of steps by k. Sorry, if we add k every time we go over a step, we need to multiply the number of steps by k to get a good start here. But for this sequence right here, that doesn't quite work. So we have a sub n equals k times n, but if I plug in 1, I get 3. And if I plug in 2, I get 6 and 9. And 3 isn't 2, and 6 is not 5, and 9 is not 8. So this isn't quite right yet. So something I'm going to have to do is I'm going to have to look at this and figure out, well, what's the difference between what I was getting and what I need to get? So I'm going to actually add some other number. I'm just going to call this c. And this is going to be to correct my formula. So k is going to be the number we add. N is the number we're on, and c is what we're going to have to use to correct the formula. And this right here is how we're going to build a formula for an arithmetic sequence. Let me show you guys how we're going to do that. So I'm going to start with an arithmetic sequence that goes 5, 9, 13, 17, and so forth. So looking at this, I can tell that every time it goes, I add 4, and here I add 4, and here I add 4. And that means that I have a pretty good understanding of where I'm supposed to be. So if I'm going to add 4 every single time, that means that my k needs to be 4. So I know we're going to start with a n equals, and then k, which is 4 times n. But then I have this plus c thing, which is going to correct my formula. So without my plus c, 4 times n is going to give me a different set of numbers than this, which is what I want. So what I need to do is figure out what I need to change. So to do that, I like to just plug in 1 for n. So figure out what the first number is. So a of n, I'm actually going to do a of 1. This is the way to write the first number, is going to be equal to 4 times 1 plus something. And I know that my first number here is 5. So 5 equals 4 plus something. And 4 plus what is 5? 4 plus 1 is 5. So my correctional number there is 1. And I'll end up finding that a sub n equals 4 times n plus 1. And just like that, I'm done. And you can rinse this, repeat it. All you do is you find our k, which is how much it goes up by every time. Then you figure out what you need to correct that by to fix it. So now we need to figure out what to do for a geometric sequence, which is a little bit more tricky, but that's all right. So what we're going to do here is I'm going to start with another sequence just so we can kind of see what's going on. So I'm going to go start with 3, 6, 12, 24, and so on. And the way we can tell this is a geometric sequence is that every time we go from one number to the next, I'm multiplying by 2. Multiplying by 2, multiplying by 2. So in this specific case, what all our formulas are going to look like is a sub n equals k to the power of n times c. So this is going to be almost the exact same thing we did for the other formula, but we're going to tweak it just a little bit. So if you notice, now it's k to the power of n instead of k times n, and we're multiplying by c instead of adding. So everything got switched a little with what operations we're using, but otherwise it's exactly the same. So last time, k was the number that we added by every time. For geometric series, it's going to be the number that we multiply. So this time we're multiplying by 2. So k is going to be the number we multiply by. If I'm multiplying by 2 every time, that means a sub n equals 2 to the n times c. So my number is going to be 2 to the n times c. I have to figure out what corrections I have to make. Again, it's really easy to plug in the number 1 here. So a sub 1 equals 2 to the 1 times c. 2 to the power 1 is 2. A to the 1 is going to be 3. So I can say that 3 equals 2 times c. And 2 times what is 3? Well, 2 times 3 halves is 3, so 3 halves is c. And I'll end up finding, draw this up here so we can see it on the same page as our sequence, that a sub n equals which is 2 to the power of n times 3 halves. And I can use this to find any number up here. Just for fun, let's do it with the fourth. So 1, 2, 3, fourth number. If I do a sub 4, should be my fourth number, equals 2 to the power of 4 times 3 halves. 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16 times 3 halves, which is going to give me 24, just like that. So 24 matches 24. That tells me that this works, and I am very happy. So just as a friendly reminder, the way we're going to find these formulas is that we are going to, depending on if we're using an arithmetic or geometric series, use the formula a sub n equals, for arithmetic, it's going to be k times n plus c. So our constant times the number of numbers we have plus our correctional. And for geometric, it's going to be k to the power of n. So we're repeating the multiplication, so it's going to be a power, and then multiplied by c, which is our correction, and we should be all good to go. So what we do is just find k by figuring out how much we're either adding or multiplying, plug in 1 for n, so we can figure out the first term, and find our correctional value here. And just like that, we have a formula for any sequence that we may find. So we should see that in class. I'd love it if you guys did the lesson practice, wrote some formulas down. It'd be awesome, and I will see you all tomorrow. Toodaloo.